Hello, welcome to Advanced Composites. Today is the second day of the 10th week of this course. Yesterday, we started discussing how the terms D1 and D16 and D26 influence the overall solution for laminated composite plates, and in that context, we started discussing the case of a simply supported plate which is symmetrically laminated, but it is having such a sequence that its terms D16 and D26 bending stiffness terms, they are not necessarily 0. And we started looking at this problem, and what we had done was that we had arrived at a formulation of the problem in terms of a special Galerkin method, and the overall governing differential equation was developed, which is shown in green, and then we started using the principle of virtual work, and within virtual work we started using special Galerkin method to solve this problem. So, we assumed that W is a sine series in two directions, sine mx pi over a, sine n pi over b, and such an assumption satisfies all the kinematic boundary conditions. The next step was we calculated the error in the equation, and that error got multiplied by a weight function or a trial function W mn1 sin pi m pi x over a times sin n pi y over b, and the multiple of this function with the error is integrated over the domain and it is set to 0. And then from this integral equation we compute the values of unknowns, which are W mn. So, that is what we are going to show in the next class in this lecture. So, here we will use a two term solution. Okay. So, W naught x y is equal to 1 to 2, 1 to 2 W mn sin m pi x over a sin n pi y over b, and the trial function is, or the weight function is similar in relation, but instead of W mn it has a coefficient 1, and that also has two terms in each direction. So, this is also sin m pi x over a sin n pi y over b. Now, if I plug this equation back in the equation which I had developed earlier, if I had developed earlier, so what I will get, I will still get a very long equation, and the overall equation will look something like this: integral 0 to a, 0 to b, and so first we will have terms related to, so just to make things a little simpler, we will call this D1 mn, this entire thing, and we will call this D2 mn. Okay, this entire thing in the bracket, because this is very long expression. So, D1 mn gets multiplied by W mn, and D2 mn also gets multiplied by W mn, but D1 mn is multiplied by sin m pi x over a, and D2 mn is multiplied by cosine m pi x over a times cosine n pi y over b. So, this is D mn and D1 mn and D2 mn, and then to compress things further, I call this D1 mn times W mn as AMN. Now, this AMN is different than our A matrix term, okay, which is A11, A12, A16, and this, when this multiplies by this thing, I get BMN. Okay. So, if I do all this, then I somewhat am able to abbreviate it, and this is what I get: A11 sin m, sin pi x over A sin pi y over B plus A12 sin pi x over A sin 2 pi y over B plus A21 sin 2 pi x over A sin 2 pi y over B, no, not 2 pi y, pi y over B plus A22 sin 2 pi x over A sin 2 pi y over B. So, in this A11 is embedded W11 times D1Mn, and in this A12 also is embedded D12 times W12, right. So, in these terms the unknown coefficients are embedded, but just for compressing it I have clubbed it into smaller chunks. So, these are the sine terms, and then I get cosine terms. So, I get V11, and then now I do not have sine, cosine pi x over A cosine 2 pi y over B plus B12 cosine pi x over A cosine 2 pi y over B plus B21 cosine 2 pi y 2 pi x over A cosine pi y over B plus B22 cosine 2 pi x over A cosine 2 pi y over B. Okay. And then there is minus Q naught B1. So, this I had erased this, but I will make this clear. So, this is pi y over B. So, this entire thing gets multiplied by the trial function, okay, which is this Wmn1, and this is also a two term thing. So, this entire thing gets multiplied by W111 sin pi x over A sin pi y over B plus W121 sin pi x over A sin pi y over B times 2 plus W211 sin 2 pi x over A sin pi y over B plus W222 sin 2 pi x over A sin 2 pi y over B. So, this is the trial function, and then I am integrating over the domain, and this entire integral is 0. Okay. Now, remember the unknown coefficients, in this coefficient is embedded W11, in this coefficient is embedded W12, and so on and so forth. Same thing in B's also W11 is embedded, in B12 also W11 is embedded, it is the same thing. Okay. So, when I do this entire multiplication, what I end up getting is essentially, and once I have integrated over x and y. So, these are just products of sines and cosines. So, I can integrate this using standard integral calculus principles, which is not difficult, and once I have integrated over the domain x ranging from 0 to a and y ranging from 0 to b, x and y they disappear. Okay. X and y disappear because I have integrated. So, once I do that, what I will get, and then we have these coefficients W11, W121, W211 and W222. Okay. So, I will get 4 blocks of terms. The first block will be multiplied by W111, plus there will be another block of terms, and this will be multiplied by W121, plus there will be a third block of terms, and this will be multiplied by W211 plus W221, and this should be 0. Huh? This is W211 and this is W221. Okay. So, this is 2 1. Okay. Now, if this entire expression has to be 0, so we will say that these are, this is T1, this is T2, this is T3 and this is T4. If this entire expression T1 times W111 plus T2 times W121 plus T3 times W211 plus T4 times W221, it has to be 0. That is going to be possible only if T1 is equal to 0, T2 is equal to 0, T3 is equal to 0 and T4 is equal to 0, because these things, because W111, W121, W211 and W221 are arbitrary, because when we do the trial function these amplitudes are arbitrary. So, we state because these are virtual displacements, are arbitrary, above equation can be 0 only if T1 equals 0, T2 equals 0, T3 equals 0 and T4 equals 0. And what are T1, T2, T3, T4? T1, T2, T3, T4, what do they depend on? They depend on M, N, A, B, D11, D12, D22, D66, D16 and D26. And what is their expression? If we do this integral, you will and arrange this entire integral in this format, we will exactly know what is T11, T1, T2, T3, T4. Okay. And here, and of course, there is Mn and then of course Wmn. So, actually here it will be W11, W12, W21, W22. So, we get 4 linear equations in W11, W12, W21 and W22. Everything else in these parameters is known, M, N, A, B, D11, all these, everything else is known. The only thing which are unknown are W11, W12, W21, W22, right. So, we can rearrange these equations in this format. Okay. So, this is a 4 by 4 matrix. So, in this matrix this is known and this is known. So, 4 by 4 matrix, everything is known except the W's. So, using this 4 by 4 matrix we can determine W11 till W22. Okay. Suppose we had 3 term solution, then we would have gotten 3 by 3 matrix. Oh, actually I am sorry, 9 by 9 matrix, 9 by 9 matrix. Okay. So, we can find out W11, W12, W22 and so on and so forth. So, this is how we get W's, but what is our original goal? We have to explore the role of D16 and D26. So, now, but we cannot explore till we know what the W is going to be. So, now that we have developed a method to figure out W11, W12, W21 and W22, now what we will do is we will start exploring how D16 and D26 influence the overall solution. We will explore their role. So, that is something we will start exploring in the next class. So, till then have a great day. Okay. Thanks.